This is an introductory video to PreSTEM algebra to help you if you need to relearn your signs rules, your positive and negative rules. Sometimes we refer to them as same signs or opposite signs. So up here it says what's the difference between the terms minus and negative. Minus is an operation. Negative indicates the opposite of a number. We'll refer to these rules a lot as same signs and opposite signs. Notice first we're going to talk about adding and subtracting. Same signs and opposite signs mean something different when you're multiplying and dividing. If two numbers have the same signs, we're going to always add them and keep the sign. If two numbers have opposite signs, you will always subtract them and keep the sign of the larger number. There's also a rule called the double negative rule, which means when you have two negatives side by side, what happens is they cancel out and they become positive. So if you look at example 1, all of these examples in example 1 are examples of same signs rules. So 2 plus 13, those are both just positive numbers. So you do just add as like you've learned in the past. If you look at letter B, you'll notice this is a -5 plus a -8. So you just add those and we get a -13. The one thing that we're going to be learning or relearning in this unit is sometimes the sign between the numbers, we like to think of it as minus, but we want to think of it more like it's the sign of the number to the right of it. So this is not like saying -12 minus 20. It's really like saying I have a -12 and a -20. Sometimes you may learn this like by putting a plus a negative underneath it or beside it, changing that to a plus sign and a negative. And so if you have, it shows, it makes it easier to see this really is a -12 and that really is a -20. I don't do this throughout the class. I pick up the sign that's in front of it and that's the sign of that number. So this is a -12 and a -20, and that makes that a -32. You add it and you keep the sign. Example D, you have 3 numbers. So when we say same signs, we're just meaning that if they all have negative numbers, then you're adding them and keeping the sign. So letter D is very similar to C. We have a -3 and a -7. So we're really adding those and we get -10. Then you can bring down your plus a -4. That parentheses is just setting it apart from the plus sign. It's not really doing anything other than that. So you're really adding those and you get a -14. So those are all examples of using the same sign rule. Example 2, they'll all be opposite rules. Again, just because two numbers have a plus sign between them, that does not mean now that we're adding. What tells us if we're adding or subtracting is the signs of the numbers. This is a +10 and this is really a -15. So those are opposite signs. One's positive and one is negative. So really you're subtracting. If you subtract this vertically, you'd want to put the bigger number, ignoring the negative sign, on top. So -15 and 10 make a -5. It's a -5 because we keep the sign of the larger number. B, we have a -2 and a +8. Again, just because there's a plus sign between them doesn't mean we are adding. I like to kind of circle them and think of them like Christmas bulbs, a -2 and a +8. I'm combining them by subtracting. So if I were to write that vertically, I would put the 8 on top, which gives us a +6. If you're writing them vertically, what you're going to notice is that's the bigger number, whichever number you put it on top, and that's where you will get the sign of your answer. Looking at letter C, again, this kind of just looks like a subtraction problem that you're used to, 20 minus 32. But because you're subtracting a smaller number, you would want to think that's like a -32 and a 20. And yes, you are subtracting but you have to put the bigger number on top if you're working that vertically. So our answer would be a negative 12. And then working with letter D, we always just work left to right when working with adding and subtracting only. If we have 20 plus a negative 3, again, those are opposite signs, so we're not really adding, we're really subtracting, and that's a positive 17. Then I could bring down my minus 7. And 17 minus 7 is a positive 10. So since that was a bigger number minus a smaller number, we do think of that like subtraction like you have learned in the past before you had to deal with positive and negative numbers. Example 3 is a column of our examples of double negatives. You'll see two negative signs side by side. And so what you want to be sure of is to always fix double negatives before you get going. And what I like to do is just make one big plus sign. So really this is like saying 17 plus 5 now. I'm just cleaning it up so we can read it easier. So you can write that vertically, or you can just go ahead and add that, and that would give you 22. And it's a positive 22 because they're both positive numbers. Looking at B, before we ever start trying to identify if these are same or opposite signs, I notice that I have a double negative right here. So I will need to change those to positive. So really this is like saying negative 5 plus 4. Now we can identify if those are same or opposite signs. In this case, they're opposite signs. So like we said above, opposite signs you always subtract. So the difference between 5 and 4 is 1, and it's negative because the bigger number was negative. Letter C, again, before I identify same or opposite signs, I see a double negative here, so I want to change that. So really, this is just simply like saying 10 plus 14. So those are same signs, you add, and you get a positive 24. Then next, before I start working left to right, I notice my double negative, so I want to fix that. I'm going to rewrite the problem to clean it up so it makes it easier to read. So we have 2 plus a negative 5 because we'll work left to right. Remember, we're not adding. We're not looking at the sign anymore to tell us the operation. We look at the signs of the numbers. This is a positive 2 and a negative 5. So since they're opposite signs, we subtract and we get a negative 3. Negative 3 plus 8. Those are opposite signs, so we're really subtracting. And this time we get a positive 5 because my bigger number was positive. If you turn the page, we're going to go over your multiplication and division rules. We still use the same terminology of same sign and opposite sign, but they mean something a little different. So in multiplying, if you multiply or divide, if the signs are the same, you always just do that operation indicated and the answer will always be positive. If the signs are opposite, you do that operation indicated, whether it was multiplication or division, and your sign will always be negative. Something to consider though, with those rules, same signs and opposite signs, you might want to start thinking a little bit about odd and even exponents. The odd and even rule. If you notice, we have 2 negatives here. That means your answer will be positive. If I have 3 negatives, your answer will be negative. If we have 4 negatives, our answer will be positive. So what that's meaning is, it says note that when there's an even number of negative factors, like 2 or 4 of them or 6 of them, the product, which is your answer, is always positive. If there are an odd number of negatives, like 3 of them or 5 of them, the product or the answer will always be negative. So a lot of times, just to make it easy to enter into my calculator, because you can use a calculator, I don't like to enter negatives in with my calculator. I would rather just multiply and decide by counting how many negative signs if my answer is positive or negative. So in this case, there's 2 negatives, so I know my answer is going to be positive. So when you multiply that in your calculator, 14 times 6, we can say it's 84. Also, I know my answer is a positive because I had 2 negatives. If you choose to enter the negative in there, you need to be sure when using this calculator that you do not use the minus sign for a negative, but you use this negative sign down here, down by that decimal point. So you can put in parentheses and say -14, and then type in it just like I see on the paper, a parentheses and a -6, and click enter, and you can see how that would still be a positive 84. Don't know if you can see that very well, but hopefully you have your calculator and you're practicing it. These two are just two positives, so you simply just multiply and it's a positive 80. Okay, here, letter C, this is why I don't always really like to use the words same signs and opposite signs with multiplication and division, because if you're looking at three numbers, they're not all the same signs. So you're really only looking at two numbers at a time if you're using that terminology. So we would work left to right on this one. -50 divided by -2 is a positive 25, and then bring down times 3. 25 times 3 is 75. Again, I didn't really have to multiply with my negatives in that. I could have counted and I saw that I had two negatives, so that's an even amount of negatives, which makes my solution a positive. Letter D, 25 divided by 5 is simply just a positive 5. Sometimes you'll see fractions and it'll look really busy if you compare E and the two E's. This one has two negatives. So again, since that's an even number of negatives, I know my answer is positive. So I can simplify this and say this will be a positive answer. So 8 divided by 4 is 2. So all of those in example 4 were examples of same sign rules or the even rule. If you have an even amount of negatives, your answer is always positive. So I like to say same or even. So my answer was always positive. Okay, you notice all of those were positives. If you look here on the next example, these are going to be opposite or odd amount of negatives. Okay, so my answer will always be negative on these. So let's see if that is true. So here we have a positive and a negative. 5 times a -3 is a -15. Opposite signs, or there was just one, which is an odd number, amount of negatives. Here, I personally would say 5 times 3 is 15, times 2 is 30. I go back and count how many negatives I have 1. So I know that that is a -30. If you're working with two numbers at a time, you'd see 5 times -3 was a -15, times that +2, they're still opposite signs, which would give you that -30. Next, we're just working left to right. We have 45 divided by a -9, which is a -5 times 3, and -5 times 3 is -15. If you didn't think about your negative sign during the operations, you would have thought, oh, I just have one negative, so I already know it's going to be a negative answer. -15 divided by 5, they're opposite signs, or there's just one negative, meaning that's a -3. Let me show you that. It got off the screen. There you go. And letter E, if you notice, we have 3 negative signs. And this is when it's really helpful also with exponents later on to know the odd and even rule. So that's an odd amount of negatives, 3 negatives. 3 is an odd number, so that means my answer will be negative. So 25 goes into 75 3 times, so my answer is a -3. The way this is reading, to explain that a little bit more, is you're taking the opposite of, you don't see a parentheses, but it's like saying -75 over -25. Well, a negative divided by a negative made that a positive, but the opposite of that still is a -3. But hopefully you're not having to break it down that much. You're just looking to see how many negatives are there. If there's an even amount of negatives, 2, 4, 6, 8 negative numbers, then it's going to be a positive answer. If there's an odd amount of negatives, just 1 or 3 or 5 or 7, then your answer will be negative.